Alright, so let's take a look at this question that is about hyperbolic functions. So it says prove the identity, and I know that sounds hard. You think, oh my god, how do I do a proof? But all you have to do is show that the thing on the left is really the same thing as the thing on the right. So what we're going to do is we're going to work with what hyperbolic cosine and hyperbolic sine really are. So you have to definitely have memorized these definitions. So cosh is hyperbolic cosine, and that is defined to be equal to e to the x minus plus e to the minus x over 2. Okay, and let me remind you about hyperbolic sine here, because it's going to come up there. So hyperbolic sine of x is defined to be equal to e to the x minus e to the minus x over 2. Okay, whoops. It's kind of an ugly line, but okay. Alright, so here's what I'm going to do. I'm just going to write down what the second side is, replacing each part here with what it is according to these definitions. And then I'm just going to do the obvious thing to it, and then at the end we'll both realize that the thing that we got is exactly this, if we think hard about what this is too. So let's just get going, okay? So I need to write cosh x times cosh y. So that is e to the x plus e to the minus x over 2. So that's one cosh. Okay, so there's a cosh x, and now let's multiply it times cosh y. So that's e to the y plus e to the minus y over 2. I should probably turn on my thing that helps me make straight lines. Plus, now let's do the second part. So this is sine h of e to the sine h of x. It looks like this, and I'll put a 2 down here. And now I do this very last one is sine h of y. Okay, so e to the y minus e to the minus y over 2. Okay, and so I guess this is the obvious thing to do, is to multiply all this stuff together. So we're going to get a big fraction over 4, right? So 2 times 2 is 4, 2 times 2 is 4. So we can think of all that as being over, just being one big fraction with 4 in the denominator. And what I have to do here is FOIL this part out. So what's e to the x times e to the y? It's the same thing as e to the x plus y. And remember, that's the way exponents work. So I'm just foiling here, first inner, outer, last. Okay. Or is it first, outer, inner, last? Right, okay. So e to the x times this thing is plus e to the x minus y. Right, I hope you see why that's true. You have to ask me in class if that is giving you a headache. Now do this one, and so that one is e to the minus x plus y. And the very last one is e to the minus x minus y. Okay, I'm going to give myself a little more space here. Alright, and now I do this one. So plus e to the x plus y, so that looks familiar. And now it is minus. Okay, so this is new, right? These were all plus, but now I've got a minus. This one is e to the x minus y, right? And now I'm going to do something kind of tricky because I'm running out of space. So I'm going to... okay. Alright, so where did this x minus y come from? It came from outer. Yeah, it came from outer. So now let's do inner. It gives me another minus. This time it's minus e to the minus x plus y. And the very last thing here is plus, because minus minus, and it's going to be e to the minus x minus y. Alright, so I hope you agree that so far we're just doing like the obvious thing, right? We got an expression and then we multiplied, and now the obvious thing to do is to collect like terms. So notice that some of these are the same, like e to the x plus y and e to the x plus y. I also get some cancellation. So this thing, e to the x minus y, it occurs negatively here, so let's cancel those things out. And this one, e to the minus x plus y, cancels out with this thing because it's got a negative version here. So now I need to combine the rest. Right, so let me write another big fraction. It won't need to be quite so big this time. Okay, so I've got two of these, right? Here's one and here's one, so I'm going to write 2 times e to the x plus y. And, alright, and I've got 2 of these other guys too, right? E to the minus x minus y, e to the minus x minus y. So it's plus, okay, so plus 2 of those, e to the minus x minus y. And this is all over 2, sorry, all over 4. And let me erase my slack fraction thing. Okay, now what do you think we do? Okay, now I say the obvious thing to do is to cancel the 2 that's in common in the top and the bottom. And if you do that, you get e to the x plus y. And here you get plus e to the minus x minus y over 2. Okay, and now there's nothing left to do that leaps out at me, so I hope we're done. So we're supposed to be done if we have shown that all this stuff equals cosh x plus y. Why is that? It's because that is what was originally on the left side of the equal sign up here. See, here he is. So what we did was we just played around with the stuff on the right, we did the natural stuff, and now is it true that what we got here is equal to cosh of x plus y? Yes, it is, because you know, remember the way a function works. You just replace the input with these symbols. So if you do that, you get that. So yes, all right. And the identity is proved, and now we're done.